Alright, so we have these things called polyatomic ions, and as the name implies, polyatomic, that means it's an ion made of two or more atoms. Like in geometry, a polygon has three or more sides, many-sided figure. So, again, these are happening because there's more stability in this situation than the elements being by themselves. So, for example, this is the nitrate ion. We have a nitrogen atom in the middle, and it's got three oxygen atoms covalently bonded around it, and it has a -1 charge. Once its electron clouds are merged together, and there's an extra electron that it gains. And these polyatomic ions are prevalent all throughout chemistry in your world. If you read the ingredient lists of many things, you can see these polyatomic ions all over the place. Nitrates, for example, are used to preserve food. If you want to know a little bit more about these polyatomic ions, there's a video on my website. You click there to see more about the polyatomic ions. But essentially, for right now, you need to be familiar with them and you need to memorize the 20 that I gave you. Because there's no predictable behavior of the polyatomic ions on paper. Like, I can't say, what is the polyatomic ion that's going to be formed when chlorine and oxygen get together? So as we can see here in this chart, chlorine by itself can be the chloride ion. Well, chlorine and oxygen can get together in a bunch of different ways. If one oxygen and chlorine get together, we call that hypochlorite. And so you can see that formula and model there. If two oxygens get together with chlorine, chlorite. 3, chlorate. 4, perchlorate. So you can see a pattern there with the names and whatnot. But really, I'm just asking you to memorize these 20 polyatomic ions. Essentially, I will give you the formulas. You have to tell me the names of these ions. So I grouped them by charge. So these are your -1 ions. And then you've got some -2, a -3 phosphate, and a couple +1s. Now, because I'm so super nice, also on the Moodle site, you can see that I created flashcards for you. So on the Moodle site, when you click on the polyatomic ion flashcards, this is what you'll see. And we've got, you can look at them this way: acetate, click to flip, that's the formula. And you can go to the next one, hypochlorite, click to flip, that's the formula. Or you can just go by formula, since that's what you'll have to recognize. ClO2 -1, oh, that's chlorite. Click to flip, yay. If you want to hear the lovely auditory, you can enable the audio.
Chloride,
Oh, and she can help you.
chlorate, perchlorate, nitrite.
Excellent, huh? You can also change study modes. You can play a game called Scatter. And there's a time, and you can go for your records. When you start the game, you can match them up. Like, okay, chromate, I believe that's CrO4 -2. Yay, I matched it, it disappeared. Permanganate, yay. If I do it wrong, this is not sulfite. Bam, nope, doesn't match. So there's a lot of different ways that you can learn to memorize these polyatomic ions, as you'll have your quiz coming up in a couple Mondays from now. Now, again, the whole reason that these atoms and groups of atoms form ions is to become more stable, and ultimately they're doing this together with each other and forming these ionic compounds. We'll get into the specifics of the bonding coming up, but these ionic compounds, you've got a positive cation and a negative anion. Opposites attract. And even though they're put together with these positive and negative ions, the electrons transfer between them and create a neutral compound, electrically neutral. And so the charge of these compounds is 0. And that's going to be important when we write the formulas. So the charge on the compound is 0. Why is this so? Because the total cationic charge, which would be the positive charge, equals the total anionic charge, which is the negative charge. And to visually see this, take our good friends sodium and chlorine. Sodium has 11 electrons and 1 valence electron on the third energy level. Chlorine, with its 17 electrons, has 7 valence electrons on the third energy level. Sodium and chlorine love to get together. Because sodium's like, I want to get rid of this valence electron. I've got a full shell underneath. Chlorine's like, hey, I'll take it. And that's exactly what happens. Sodium's valence electron goes over to chlorine. Its third energy level is no longer occupied. It has a full stable shell, just like a sodium, or I'm sorry, like a neon atom with 10 electrons. But because of that, it lost the electron. It becomes a sodium +1 ion. Chlorine gains it, becomes a chloride ion, and it's happy as well because it has a full shell. So essentially, sodium's valence electron is transferred to chlorine. And of course, this doesn't happen on a one atom to one atom basis. We're talking about gabillions of these happening at the same time, moles worth. And so you end up having these beautiful crystalline structures where the sodium and chloride ions are put together in a very nice pattern, balancing out the charges, and it's a 1-to-1 ion ratio. So the formula of sodium chloride is NaCl. It's one of our FUs, a formula unit. So we're going to see how to write some of these ionic compound formulas based on the fact that we've got to be put together with a zero neutral charge.